In this video, we will talk about how to configure policy-based routing on Sangfor IAM. IAM routing mode and bridge mode support policy-based routing, DSCP enters mark. There are two types of policy-based routing, which are default policy-based routing and preferred policy-based routing. For default policy-based routing, it consists of the following link load balancing policy. Prefer the line with highest priority, based on destination ISP, based on remaining bandwidth, weighted round robin, even load assignment and disable default policy. For preferred policy-based routing, it consists of the following link load balancing policy. Specified line selection, balance load among links, based on remaining bandwidth, prefer the link at top, weighted round robin, even load assignment and make VPN tunnel standby link. In this tutorial, I will show you a case study about policy-based routing. The customer has two external network lines, one ISP1 and one ISP2. They want the traffic data accessing to shopping sites and social media sites from the internal network goes out via ISP1, while other traffic data goes out via ISP2. Based on the described scenario, we can: Step 1. Configure preferred policy-based routing. Step 2. Select the corresponding application in policy. Step 3. Select the corresponding outgoing line. Now, I will demonstrate on how to configure policy-based routing on Sangfor IAM. The picture shown here is our sample topology for this tutorial. First, go to Bandwidth Management, Link Load Balancing. Click on Enable Link Load Balancing Policy. Make sure the line state detection are configured and status is normal. Move the mouse over to Priority Description to know the different routing priority. From here, we can select different default link load balancing policy and view its explanation and function. In this tutorial, we will be configuring preferred policy-based routing. Go to Preferred Policy-Based Routing. Click on Add to add new policy for ISP1. Give a name to the policy. Select the applicable user, application, network group, and service. In this tutorial, we will select all users, network groups and services. For applications, we will be selecting all social networking and shopping. Go to Line Selection. Select Specified as line selection. Select 1.1 as outgoing interface. After done settings, click Commit. Add another new policy for ISP2. In this policy, we will be selecting all applications except the social networking and shopping. Select 1.2 as outgoing interface. After done settings, click Commit. From here, we can see that our policy has been created. Until here, the configuration for policy-based routing has been done. Now, we will test the result using an internal PC. You can go to Status, Traffic Statistics, Link Load Balancing Status to view the status of the line, bandwidth utilization, and the distribution of the traffic diversion policy. First, we will begin the testing by accessing to shopping and social media sites such as Lazada and Facebook. We will access to the sites via browser and tracer command, and view the traffic status in Link Load Balancing Status. Click on ISP1 line to view the real-time application traffic. As we can see, the traffic to the sites has been recorded down in ISP1 real-time traffic status. We can also see that the traceroute results going to Facebook and Lazada is going via 192.168.19.1, which match the next hop address of the ISP1. Now, we will access to other sites such as BBC News and Yahoo. As we can see, the traffic to the sites has been recorded down in ISP2 real-time traffic status. We can also see that the traceroute results going to the BBC and Yahoo is going via 172.16.1.1, which match the next hop address of the ISP2. In conclusion, the policy-based routing has taken effect. Precautions. If there are multiple external network lines, you need to configure link state detection function. Otherwise, the link load policy does not take effect. The default load policy cannot customize the user, application, validation time. Turning on global exclusion and pass-through does not make the link load function lose packets. The function is still effective.